Difference between inverter AC and non-inverter AC. Hello everyone, welcome back to the channel. In today's video, we will discuss one of the most common questions asked by homeowners and HVAC students. What is the difference between an inverter AC and a non-inverter AC? Many people believe that an inverter AC simply means less electricity consumption, but there is much more to understand. In this video, we will explain the working principle, electricity consumption, advantages and disadvantages of both systems, and finally, help you decide which one is better for your needs. What is an inverter AC? An inverter AC is an air conditioner that uses variable speed compressor technology. Instead of operating at only one fixed speed, the compressor can speed up or slow down according to the cooling demand of the room. When the room temperature is high, the compressor runs faster to provide rapid cooling. As the desired temperature is reached, the compressor slows down and maintains the temperature without completely shutting off. This continuous adjustment helps improve comfort and energy efficiency. What is a non-inverter AC? A non-inverter AC uses a fixed-speed compressor. The compressor operates in an on and off cycle. When the room temperature rises above the thermostat setting, the compressor turns on at full capacity. Once the desired temperature is reached, the compressor shuts off completely. As the room warms up again, the compressor restarts. This repeated start-stop operation continues throughout the cooling cycle. Working principle: how an inverter AC works. The inverter technology controls the compressor motor speed by adjusting the electrical frequency supplied to the compressor. For example, if only 50% cooling capacity is needed, the compressor slows down and operates at a lower speed rather than stopping completely. This provides more stable indoor temperatures and reduces energy waste caused by frequent starting and stopping. How a non-inverter AC works. In a non-inverter system, the compressor runs at one speed only. The thermostat detects room temperature and switches the compressor on or off accordingly. When cooling demand exists, the compressor operates at full power. When the set temperature is achieved, it shuts down completely. Frequent cycling may result in larger temperature fluctuations and higher starting currents. Electricity consumption. One of the biggest differences between these two systems is energy consumption. An inverter AC is generally more energy efficient because it adjusts its capacity according to the actual cooling requirement. Since it avoids frequent compressor restarts, it often consumes less electricity during extended operation. A non-inverter AC typically consumes more electricity when used for long periods because the compressor repeatedly starts at full capacity. However, it is important to understand that actual energy savings depend on factors such as room size, insulation, thermostat settings, maintenance, and usage patterns. If an AC is used only for very short periods, the energy-saving difference may be smaller. Advantages of inverter AC. One major advantage of inverter AC systems is lower electricity consumption during continuous operation. Another benefit is improved comfort because the room temperature remains more stable. Inverter systems also operate more quietly since the compressor usually runs at lower speeds after the desired temperature is achieved. The reduced compressor cycling may also decrease mechanical stress on components. Disadvantages of inverter AC. The main disadvantage of inverter AC units is their higher initial purchase price. Their electronic control systems are more advanced and may require specialized knowledge during troubleshooting and repair. Replacement parts, such as inverter boards, can also be more expensive compared to conventional systems.
Advantages of non-inverter AC. Non-inverter AC units usually have a lower purchase cost. Their design is generally simpler, making them easier for many technicians to diagnose and repair. In some areas, replacement parts may also be more readily available and affordable. For users with limited budgets, non-inverter ACs can still provide effective cooling. Disadvantages of non-inverter AC. The repeated on and off operation may result in higher electricity consumption during extended use. Temperature fluctuations are often more noticeable because the compressor completely stops after reaching the set temperature. Some users may also experience slightly higher noise levels due to frequent compressor startup. Which one is better? The answer depends on your needs and budget. If you use your air conditioner frequently for many hours every day and want improved energy efficiency, quieter operation, and better temperature control, an inverter AC is generally the better choice. On the other hand, if your budget is limited and you use the AC only occasionally, a non-inverter AC may still be a practical option. There is no single system that is perfect for everyone. The best choice depends on how often you use the unit, electricity costs in your area, and your long-term priorities. Quick comparison. Inverter AC, variable speed compressor, lower electricity consumption during long use, more stable temperatures, quieter operation, higher initial cost. Non-inverter AC, fixed speed compressor, on-off operation, lower purchase price, simpler design, higher energy consumption during extended operation. Conclusion. Understanding the difference between inverter and non-inverter air conditioners can help consumers make smarter purchasing decisions and help HVAC students build stronger technical knowledge. Inverter ACs focus on efficiency and comfort, while non-inverter ACs offer simplicity and lower initial investment. Both technologies have their own advantages and disadvantages. Thank you for watching. If you found this video helpful, don't forget to like, share, and subscribe for more HVAC training videos, troubleshooting guides, refrigeration lessons, and educational content on heating, ventilation, and air conditioning.